Welcome to Q.com Media. Let's learn together. This is Artificial Intelligence Part 2. I highly recommend that you want the Part 1 video. There are a number of different XAI techniques that can be used to explain AI models. Some of the most common techniques include local explanation. This technique explains the decision of an AI model for a specific input. For example, a local explanation could explain why an AI model predicted that a person would be likely to default on a loan. Global explanation. This technique explains the overall behavior of an AI model. For example, a global explanation could explain how an AI model makes decisions about which products to recommend to customers. Feature importance. This technique identifies the features that are most important for the decision of an AI model. For example, a feature importance analysis could show that the age of a customer is the most important factor in predicting whether they will default on a loan. AI is a rapidly growing field, and there are a number of new XAI techniques being developed all the time. XAI is an important tool for that AI models are transparent and understandable, and it is likely to play a major role in the future of AI. Here are some examples of how XAI can be used in practice. A bank could use XAI to explain why it denied a loan application. This would help the applicant to understand the decision and to appeal the decision if they believe it was unfair. A hospital could use XAI to explain why it recommended a particular treatment for a patient. This would help the patient to understand the treatment and to make informed decisions about their care. A company could use XAI to explain why it targeted a particular customer with an advertisement. This would help the customer to understand why they were targeted and to make informed decisions about whether to click on the ad. AI is a powerful tool that can be used to make AI models more transparent and understandable. It is an important tool for ensuring that AI models are fair and accountable, and it is likely to play a major role in the future of AI. Reinforcement learning, RL, is a type of machine learning where an agent learns to behave in an environment by trial and error. The agent is not explicitly programmed with the rules of the environment, but instead learns by interacting with the environment and receiving rewards for taking actions that lead to desired outcomes. Here is a simple example of reinforcement learning. An agent is placed in a maze with a cheese at the end. The agent does not know the rules of the maze, but it can move left, right, up, or down. The agent receives a reward of +1 for getting to the cheese and a reward of 1 for hitting a wall. The agent starts to explore the maze, taking random actions and receiving rewards. Over time, the agent learns to take the best actions to get to the cheese, and it receives a higher reward as a result. This is Artificial Intelligence Part 2. I highly recommend that you want the Part 1 video. Reinforcement learning is a powerful tool that can be used to solve a variety of problems, including game playing. Reinforcement learning has been used to develop agents that can play games at a superhuman level, such as chess, Go, and StarCraft. Robotics. Reinforcement learning is being used to develop robots that can learn to perform complex tasks, such as walking, grasping, and object manipulation. Finance. Reinforcement learning is being used to develop trading algorithms that can make decisions in real time to maximize profits. Healthcare. Reinforcement learning is being used to develop agents that can learn to diagnose diseases, recommend treatments, and personalize care plans. Reinforcement learning is a rapidly growing field, and there are a number of new RL algorithms being developed all the time. RL is an important tool for solving complex problems, and it is likely to play a major role in the future of AI. Here are some additional details about reinforcement learning. The agent in an RL problem is typically a software program that can interact with the environment. The environment is the physical or virtual world that the agent is trying to learn to operate in. The reward function is a mathematical function that assigns a value to each state-action pair. The reward function tells the agent how good or bad it is to take a particular action in a particular state. The goal of the agent is to maximize its expected reward over time. This means that the agent wants to take actions that will lead to the most rewards in the long run. Reinforcement learning is an iterative process. The agent starts by exploring the environment and taking random actions. As the agent receives rewards, it learns to take better actions that lead to more rewards. Reinforcement learning is a challenging problem, but it is a powerful tool that can be used to solve a variety of complex problems. Transfer learning is a machine learning technique where a model trained on one task is reused as the starting point for a model on a different task. This can be helpful when there is limited data available for the new task, or when the new task is similar to the old task. Here is a simple example of transfer learning. A model is trained to classify images of cats and dogs. This model is then used as the starting point for a model to classify images of flowers and trees. The new model does not need to be trained from scratch. Instead, it can be fine-tuned using the data for flowers and trees. Transfer learning can be used to solve a variety of problems, including image classification. Transfer learning can be used to classify images of different objects, such as cats, dogs, flowers, and trees. Natural language processing. Transfer learning can be used to process text, such as translating languages, writing different kinds of creative content, and answering your questions in an informative way. Speech recognition. Transfer learning can be used to recognize speech, such as transcribing audio recordings and controlling devices with your voice. Robotics. Transfer learning can be used to control robots, such as navigating through a cluttered environment and picking up objects. Transfer learning is a powerful technique that can be used to save time and resources when training machine learning models. It is also a way to improve the performance of models on new tasks by leveraging knowledge from related tasks. Here are some additional details about transfer learning. The model that is reused is called the base model. The model that is fine-tuned is called the target model. The base model is typically trained on a large dataset of labeled data. The target model is typically trained on a smaller dataset of labeled data. The target model is fine-tuned by adjusting the weights of the base model. The fine-tuning process is typically done using a technique called stochastic gradient descent. Transfer learning can be used to solve a variety of problems, but it is most effective when the new task is similar to the old task. That's all. Check the Artificial Intelligence video Part 1. Visit our website for more information. Thanks for watching. Subscribe to keep in touch. Visit our YouTube channel for more videos and our website https://q.com.